All right, so welcome to our next interview at Night Hacking at JFocus. I'm Stephen Shin, and with me I have Jim Manicode, and we are going to teach you how to secure your Java programming in 10 minutes. Disclaimer, this is not actually a security course, and any damage that results is from the practices we expound here, we're not liable for.
We'll at least get the conversation started, Steve.
Yeah,
how's that?
Yeah, there we go. Okay, Jim, so tell us a little bit about what you do and who you are, and then we'll go through some of your security.
Sure. My name is Jim Manicode. I'm one of the board members of the OWASP Foundation. I'm an independent secure coding trainer. I teach developers around secure software design and development. And I'm from Hawaii. Aloha, everyone. Hello to my friends out there in the islands.
You seem slightly underdressed for the Stockholm wintry weather here.
Yeah, I mean, not so much into the thick jackets, gloves, or hats. I'm more into like the Hawaiian shirts and shorts and sandals kind of thing.
Yeah.
That's my preference.
So you walk around town like this?
No, actually, this is overdressed for Hawaii. I tend to have shorts, sandals, and yeah, that's how I tend to roll. Nice.
Okay, so you said that you had 10 different secure practices you wanted to cover.
Yeah, one of the projects I work with at OWASP, and as a quick note, even though I'm a board member of OWASP, I'm going to talk about an OWASP project. OWASP is a vendor-neutral, nonprofit organization. They don't endorse any of my commercial activities or anyone's commercial activities. It's just a nonprofit organization that I work with. So, you know, my commercial activities and my OWASP nonprofit activities, I firewall them as much as possible to try to remain ethical. So,
cool.
That aside, I'm going to talk about an OWASP project called the OWASP Top 10 Proactive Controls. It's just a project I'm working on as an awareness document to teach devs about secure coding. So the first of 10. Are you ready for one of 10?
Wait. Okay, I'm ready.
Yes. I think and a lot of these are boring, but the work of security is not when you do hacking. No offense to night hacking, that's a different kind of hacking. The real work in security is when you're designing secure software and writing lines of code using proper security controls or defenses. That's where the work is done. And it's minutia, it's detail, it's not even glorious. It's, you know, when you're coding and sweating and getting stuff done, that's where the security is done. And we're going through a culture change now where years ago it wasn't that important. Today, it's never been more important. So number one, secure architecture and design. You know, we want to plan the dive and dive the plan. Regardless of whether we're doing Agile or DevOps or traditional waterfall, we're all going to have some kind of process to think about how we're going to build software before we build it. And there's
do you ever get any pushback from the Agile community about security practices or how you integrate it with their more fluid development style?
No, I don't think so, because keep in mind, when you talk about Agile is not about quickly writing crappy software. Agile is about iterative approaches, iterative, high-quality software release. So it's not like we're just slapping stuff together. A true Agile team has a disciplined and well-thought-out architecture, really elite processes and redundancy in programming, and they have baked into that Agile process the ability to quickly release high-quality software. Now, a lot of Agile teams, they take the good of Agile, let's let my manager change requirements, low documentation, they take the fun parts of Agile and embrace that, but the disciplined part of Agile, many people throw away. So if you're throwing away the disciplined part of Agile, you know what you are? You are not Agile. So we need that discipline, and part of that discipline is a strong architecture, and part of a good strong architecture is, Stephen, that's right, security. Security controls.
I think I'm going to be good at these questions.
Awesome. So when I think about security design, let me give you an example. Suppose we're doing, we want to save a variable that's tracking how many times the user has failed to log in successfully. So if they exceed some threshold, we'll lock the account. Now, this isn't a perfect control, it's just an example. So if I want to implement that, I have to save an integer of current failed number of login attempts for that user. Where do I stick that variable?
I know. In the browser cookies.
Fail. So do I put it in the request, in a browser cookie, or a hidden variable? I've seen that before. And as the attacker, we can change that all day. Do I put it in the session, or do I put it in the database? A lot of people will say you put that variable in the session, or I can just drop the cookie and get a new session every time. So if I want to track the number of failed login attempts per user, that's got to be in the database,
so
unique for every user. Yeah, it's got to be persistent.
Yeah.
And so, as a developer, though, I can stick it in the session, and it's going to work.
Wait, hold on. Pop the mic. We're running out of battery. Now we're good.
All right.
All right. How's that for Agile presentation?
Perfect. So as a developer, I can take that variable, failed number of login attempts, and I can put it in the session, and it will appear to work all day long. And even QA testing it, it will appear to work in some scenario. So,
but very easy for an attacker to write an automated application, bypasses it, just continually spams with new passwords till they crack it.
Exactly, Steve. So we want to, as much as we can in design, we want to specify some of these design patterns and keep security in mind when we do it.
Yeah.
That's a very simplistic example. Now, and design covers threat modeling, business logic design, and much, much more than just that small example. But what should fall out of a good design process is a series of requirements. Mm-hmm. Number 2 in our proactive approaches to secure coding. We want to have good requirements so we can prescriptively tell developers not just how the application should work, but what the security properties of that software should be. Hey developers, who out here, I'm just curious, who out here happens to be a Java developer? Anyone? Yeah. So how many times in your career have you been given a series of clear requirements that define how you code that application securely? You have 0. Okay, you went, yeah, right. But we can do this, and we should do this. Here's an example. Out of a good design process, we should have at least 2 major kinds of requirements. The first are functional security requirements. Like if I'm going to do the forgot password workflow, or change password feature, or the edit user feature, there's going to be security properties in all of those functionality, and that's stuff that a QA person can test easily. Another class of security requirements are non-functional requirements. These are things that are not visible, that a normal QA tester can't easily test, and we usually need security specialists to test it. And an example of that would be like a non-functional requirement. All your queries should be parameterized. Your password storage system should use an HMAC or an adaptive hash. And then we have business logic requirements, and now more important than ever, well, it's really important in Europe, but it's not so important in the US, privacy requirements. But yeah, so this is what should fall out of a good design process, is a list of requirements that I can give to a developer. Now, most people say, you must write secure code, and as a developer, you're like, well, how do you do that? And well, I don't know, just go figure it out. That's a path to failure. So we should spec out what the security properties of software should be. This is ideal, but you end up saving a lot of money and resources.
So if you're getting your requirements from a product manager, a product owner, or somebody who's driving what your application should be like, how do you educate them on what they should be giving you for security requirements?
If you have a product manager who's driving technical requirements that really knows nothing about security, there's a lot of frozen lakes in Sweden we can drop them into. It's going to lead to disaster. So it's fundamental that you have security buy-in from the C-level down. And especially when you're talking about product managers, technical project managers who are driving developers' time, if you don't budget security into that, it's a path to failure. And again, if you look back 5 years, security requirements didn't matter so much. The whole world has changed. This is the golden era of hacking.
Yeah.
Security hacking, not just code hacking.
We wear white hats on this show.
Right on. Right, I'm with you. I'm with you there. So yeah, that's the next thing, is good, prescriptive, functional, non-functional, business logic, and privacy-centric security requirements. Let's go to the next one. You ready?
Yeah, ready.
So number 3, Now we're getting a little bit more technical. We want to leverage the security features of our frameworks and good security libraries. If we find ourselves building our own custom input validation layer, if we find ourselves building our own custom output encoding library, if we're doing password storage from scratch every time we write code, it's a failure. So we want to have good, reusable, this is just normal OO, normal good development.
Yeah, but it matters more for security because those are things which, if you're using an open source library, if it's getting people reviewing the code, if people are contributing security patches, then you don't have to do that yourself.
Exactly, and it's difficult in the Java ecosystem to find good security libraries, I think. And so some of the ones that I work with at the OWASP Foundation is the OWASP Java Encoder Project, the OWASP HTML Sanitizer Project, the Apache Shiro is a good access control project. Google has a project called Keyzar, which is just one of the best crypto libraries in the Java ecosystem. And by leveraging these very well designed and well thought out and well maintained security libraries, it enables us to build secure software more efficiently and with long-term maintenance of those controls in mind as well.
Cool.
Let's move on. What's number 4? Let's charge on. And this is a giant topic: identity and authentication. This is something that individual developers doing day-to-day work should not be doing. There should be some kind of standardized layer standardized components that is custom to our business that we can roll out.
This is a big problem for the Internet of Things because you have all these devices talking to back-end services, and they really don't know your identity. They're exposed to man-in-the-middle attacks, all sorts of ways you can exploit these.
Yeah, we'll just use the Facebook login button on everything and you're good to go. I am kidding, by the way. No offense to Facebook, but it's a lot of the trends of consumer software is to use federated identity, the Facebook, Twitter, and other login systems. And for high security software, I'm not a fan. It's not the right way to go.
Yeah.
And so, so let's leverage what frameworks we can. Let's audit them well. Let's use them properly.
Hold on.